All right, we're going to talk about polynomial functions and modeling. Understand that all modeling is just using an equation to represent some real life situation. Okay? So polynomial functions, p of x equals a sub n, x to the nth power, plus a sub n minus 1, x to the n minus 1, all the way down to a sub 1, x plus a sub 0. So these are here's some examples of different polynomials. We go up to cubic here, but they can go up to any power. So a constant, f of x, this is 0 degree. My lead term is 3, and my lead coefficient is also 3. I have linear, which you guys are really familiar with. F of x equals 2/3 x plus 5. That's degree 1. My lead term is 2/3 x, and my lead coefficient is 2/3. Quadratic, f of x equals 4x squared plus 6. My degree is 2. My lead term is 4x squared, and then my lead coefficient is 4. The cubic, f of x equals 5x cubed minus 6x plus 7. My degree is 3. My lead term is 5x cubed, and my lead coefficient is 5. It's really important to understand this lead term and the lead coefficient because we're going to use this information later on. The domain of a polynomial is always negative infinity to positive infinity because we're always in this form. So there is no domain restrictions in there. So when we're talking about polynomials, a lot of times we want to know what happens at its extremes or its ends. So we're going to talk about end behavior and how that lead term determines it. So remember our lead term is a sub n x to the nth power, okay? So if n is an even, so if it's an even power, if my degree is even, okay, what I'm going to have is I'm going to have my end behavior is going to go in the same direction, okay? So if a sub n is positive, so if my lead coefficient is positive, I'm going to end up going up and up, okay? So we kind of talk about as x is going to infinity, so as x is going this way, what's happening to y? And as x is going to negative infinity, what is happening to y? Well, if a sub n is positive, as x goes to positive infinity or negative infinity, y is still going to positive infinity. If a sub n is less than 0, or if it's negative, they're both going to go down, so they're both going to go to negative infinity. Now, odd powers are a little bit different because odd powers cross through the x-axis. So one side is going to have a positive y value and one side is going to have a negative y value. So if a sub n is positive, as x goes to infinity, so this part over here, we go to y is going to positive infinity. As x goes to negative infinity, y goes to negative infinity. And then it's the reverse when a sub n is less than 0. So as x goes to infinity, y goes to negative infinity. As x goes to negative infinity, y goes to positive infinity. So this is how we're going to write it out. So here I have f of x equals 3x to the fourth minus 2x cubed plus 3. Okay? When I'm dealing with these, and you probably notice up here in my diagrams, there's all these little bumps. The reason is because I don't really care about how many terms it has in the middle. I'm only talking about the extremes. All right? So what I really want to know is I really want to look at my lead term and my lead coefficient. Well, here's my lead term, 3x to the fourth. Now I know the degree, it's 4, so it's an even power, so it either has to go, both have to go to positive infinity or both have to go to negative infinity. I look at positive 3, okay, so it's positive, so these are both going to go to infinity. And you can kind of think of it this way. If I plug in a positive number here, a positive number to the fourth power is positive. So 3 times positive is positive, positive infinity. If I plug in negative infinity to the fourth power is still going to give me a positive number. So I end up with a positive times a positive, which is a positive. So my next one, f of x equals negative 7x to the fifth minus 3x squared plus 6. Well, now I'm an odd power. I look at my lead term. Here's my lead term. 7, my lead coefficient is negative. So now I end up in this, okay? So a sub n is negative. So now I know that this is going to be negative infinity and positive infinity, okay? So as x gets positive, this becomes negative, right? Because if I plug in a positive number to the fifth power, it's still positive. Positive times a negative is negative, so negative infinity. If I plug in a negative number to the fifth power is negative. Negative times a negative is positive. That's where I get my positive infinity. Okay? So our next example here is p of x equals x cubed plus x squared minus 17x plus 15. And it asks, are 2 and negative 5 zeros of p of x? Okay, well, the way we're going to test that is we're going to plug it in. So p of 2 equals 2 cubed plus 2 squared minus 17 times 2 plus 15. That gives me 8 plus 4 minus 34 plus 15. 12 and 15 is 27, so that gives me negative 7. Okay, negative 7 is not 0, so 2 is not a 0. Now we're going to test p of negative 5. So I have negative 5 cubed plus negative 5 squared minus 17 times negative 5 plus 15. So this gives me negative 125 plus 25 plus 17 times 15 is 255. Plus 15. Minus 25. And so then we end up with negative 125 plus 25 plus 255. Oh, this is not 255, sorry. 17 times 5 is 85. That should have been 85, which gives me 0. Sorry about that. Okay, I did 17 times 15, which it's not 17 times 15. So, so negative 5 is a 0, 2 is not a 0. The next thing we're going to do is we're going to find the zeros. Well, if this is my piece here, I know that I have a 0 for each of these parentheses. So I could really look at this as, well, here I have 2 is a 0 here, right? So I have 2 is a 0, 2 is a 0, 2 is a 0, and negative 1. And so this gives us what we call multiplicity. So multiplicity is when a number appears as a 0 multiple times. So another way we could write this is 5 times x minus 2 to the third power times x plus 1. Okay? So here I have 2, it happens 3 times, it's that power. So it has this multiplicity of 3. And we're going to talk about what multiplicity means. So multiplicity just means that that number appears multiple times as a 0. But if it is an even multiplicity, then what's going to happen is the graph is going to be tangent to the x-axis. So it's going to come up to the x-axis, looks like it kind of bounces off of it and goes in the same direction that it came from. Okay? If it's an odd multiplicity, it's going to cross the x-axis. Okay, so it's going to go up to the x-axis, cross through it, go to the other side if it's odd. Depending on this even or odd multiplicity, we'll give it more of that degree look. So here I had a multiplicity of 3. So as we come up on 2, it's going to look more like a cubic function, okay, as we're coming through. Even though this is not a cubic function, this part, if I look at just a small window, right around 2, it's going to have that smoothness of a cube right there. Okay, so here it says find the zeros. I know that I have 3 zeros here. So what I'm going to do is I'm going to group this. I'm going to do some grouping techniques. And here I'm going to pull out an x squared. So that gives me x minus 2. Here I'm going to pull out a negative 9. And that gives me x minus 2. So now I have x squared minus 9 times x minus 2. This still factors into x plus 3, x minus 3, and x plus 2. So now my zeros are negative 3, positive 3, and negative 2. There's my zeros. It crosses at each one of those. It's an odd multiplicity. They all have 1. So that kind of gives us that look to it. The last thing is just understand that all these polynomials can be used to in real world situations. Okay, so we can actually go through and take a real world application, apply it with a polynomial, and solve it. That's our modeling side of it.